We got homework yesterday.
Yeah, we did.
Yeah, we did lunch.
Did we actually get homework yesterday?
Yeah, it was like 20 questions.
Yeah,
It was due Monday.
Are you lying?
Yeah.
So we did the homework one?
I
Why?
He wasn't here yesterday. How would you know this stuff is here? Because we got through the notes with like 30 minutes left in class. So then this stuff is just like, here's an assignment that's due Monday. I'm going to use that assignment yesterday. Yeah, see, she even said she gave us some worries. I'm not going to do that.
You know what's sad? I care. Did you actually get used to it? Used to nervous.
Yep.
You're real lazy people.
Theo.
Yeah, you're supposed. I don't know if you actually.
Tyler, I heard that cold bitch.
Holy crap, yeah.
You know what?
Like, I'm about to extend
Hey, you need your notes up, please. Make sure you have your notes up. No, I'm just going to turn you loose.
We didn't do it. Do it and see how we do for you. Because, it was interesting.
You'll be fine. All right. Let me pop up the grid back up on the board here. Just wait out.
I'm out of data.
All right. Hey, just to let you know, we're in section 1-1. All right. Now, today's the last section 1-1. I said we're going to do about a section a day. We'll get notes every other day, kind of a thing, where they're pretty straightforward. Today is to kind of discuss what we didn't get yesterday, what you didn't quite understand, whatever those parts are. So it's going to be pretty basic. Again, what we're doing today is what we're talking about is graphs and linear equations. Graphs and equations. Now, most of them are linear, so that's just what you need to realize. And I'll kind of show you the idea between a linear equation and a nonlinear equation. That's going to be the idea today. All right, now we have a couple different topics. Number one, let's do a quick review of the coordinate plane. You know, the terms that I'm going to use, the vocabulary terms I might use throughout the sections, so that you are very, very comfortable with those. Okay? Once we're through that, then what I really want to discuss is how could we graph with that? Is it possible to graph equations on a coordinate plane? Now, if I gave you an equation, and I'll show you kind of what I expect you to be able to do. So we'll do maybe an example or two of graphing. I'll show you linear, maybe a nonlinear equation, that kind of thing. Then our goal is what I want to finish with is I want to try to finish with the tables. Now, explain how a table works. You know, how you can read it, what it's actually telling you, that type of thing. Okay? Does that make sense? Like 3 little check marks that we covered today. That's it. Very, very basic. We get a chance to work on homework today, that's what we'll do. If we don't, not a big deal. I know I was gone yesterday. So today is to get us up to par with where I wanted us to be yesterday. So let's talk about the Cartesian coordinate system. So that is this object right here. Make that a little bit bigger so you can see it. Okay, this is a coordinate plane, right? Has an x-axis and a y-axis. Origin is the middle. It's where the dark axes actually meet. Now, what you need to realize is that these boxes, these grids, technically are not there. What they're doing is they're extending the little hash marks that you have for like 1, 2, 3, 4. They're extending them and they're just running into each other. So it's making little grid-like patterns. Most people are very familiar with them, but you need to realize all these little check marks, all these little boxes are just signifying numbers on the actual grid itself, the coordinate plane. Now it's very old. It's made 17th century by a French mathematician. We still use it for a lot of different things. We still use it for, basic mapping programs like GPS coordinates on a computer, on your phones. It actually controls the screen and pixels on your Chromebooks or your MacBooks or your iPhones or Android phones. That's the system that they still use. So that's like if you ever use those high-end graphing programs like Photoshop. You'll know when you start moving the cursor on Photoshop down in the corner, it'll start listing coordinates, numbers. These numbers will be constantly changing because it's what pixel your cursor is actually on. That's what it's telling you. Okay? Because that's how the screen works. But what we need to do is kind of figure out the different terminology here. So, do we feel comfortable with x-axis? It's actually labeled. Most of the graphs I will always give you, they'll always be labeled so you know. The y-axis, I'm comfortable with that one. Now, for coordinates, or what we refer to as an ordered pair. It's a way of getting around the grid system. That's the idea. So why they call them ordered pairs? They're in alphabetical order. So how this works is that they're going to be in parentheses like this. They're going to be separated by commas. Alphabetical order. So which axis comes first? X, because alphabetically X comes before Y in the alphabet. That's just how it works. That's why it's called an ordered pair. You can pick any combination of numbers, and negatives, positives, zeros, decimals, it does not matter. As long as you understand what this is actually telling you. So like for instance, 12, comma, 1.5. How I get around? I know I need to go on the x-axis first, figure out where 12 is. So the example that I always give, which is pretty close to Ms. Stephen's example, is what I always say is imagine you're walking into a hotel lobby. So this is the hotel lobby. This is like the front door of that hotel. This is ground level. You have to pick the elevator you're going to get into. So this is the 0 elevator, 1, 2, 3, 4. That's how they're labeled. Or -1, -2, -3. That's how they're labeling all the elevators from the lobby. Once you pick your 12th elevator, that one, now you can go up and down in it. So what floor am I going to? Yeah, I'm in between 1 and 2. So here's the first floor. I'm right in between floors. So the elevator stopped here. That's where you are. Does that make sense? Now, if there was a letter, let's say that I gave you a letter A out here, you could label it. Instead of drawing, instead of just putting a dot here, just put the letter A next to it. You don't need to put the numbers. Just put A. You're good. Does that make sense now? Pick the elevator, then go up and down. Because just think about it in that terms. Now it makes more sense when you pick zeros. It makes sense what you're doing. Okay, so for instance, can somebody just give me a random number that's less than 12? 7. Okay, so we'll do, the next one will be 7, comma 0. Okay, so I'm going to pick 0. So that means the first number is my x. That's the elevator I'm getting into. So I'm getting into the 7th elevator. 1, 2, 3, 4, 5, 6, 7. The door's closed, and did I go anywhere? No, I just stayed there. I forgot to push the button. Okay, because I'm still at ground 0, 0 floor. Okay, somebody pick a different number, please. 6. Okay. C is 0, comma 6. So now I need to pick the 0 elevator, which is the one right in front of the lobby door, and now I'm going to the 6th floor up. 1, 2, 3, 4, 5, 6. There's letter C. Okay, do we feel comfortable with how to graph coordinates? That's something you've done since what? 7th grade, 8th grade, something like that, maybe even earlier than 6th grade, if you were lucky. So, but we can get to any spot on here and we can come up with different combinations, different equations that would give us actual graphs on here and actual lines or curves. So that's the idea. Now, the other things we need to know from this graph. Obviously, do we feel comfortable with the word origin? What is the origin? Yeah, it's the middle, right? The origin, that word, is actually used on number lines as well. On just a traditional number line. The origin's the middle, right where 0 is at. Okay? So that makes sense because this coordinate plane is literally made from a number line and another number line at a perpendicular angle, 90-degree angle. So this is a number line, that's a number line. That's why this makes sense. They still call the origin. The middle above. Okay, that's where you base everything off of. That's how I graph coordinates. I start on the origin every single time, and then I go from there. Okay, so that's x, y-axis, coordinates, origin. The next term is quadrants. So that would be my next term. Now, how many quadrants do we have?
4.
4. Okay. They are just, what a quadrant is, it's the space that covers a series of coordinates. Okay, it's a space, it's a location. So where would coordinate 1 be?
Top right.
Top right. Okay. This is quadrant 1. Now notice how I number it. Roman numerals. I don't use digits. I use Roman numerals. Digits are saved for coordinates, ordered pairs. That's where we use digits for. Roman numerals are for quadrants. It's the area. Now, here's what you also need to realize. Okay, on this picture, and I think that graph all of a sudden.
Yeah.
Move a little bit ago.
Pretty bad news here.
Weird. All right. Okay. So, all right. But anyway, on this graph, if let's say these are my coordinates, right? Yeah, let's say that it's this. There's only one coordinate in quadrant A, quadrant number 1. And it's letter A. You know, point A. That is the only coordinate that's found in quadrant 1. Point C there is in between quadrants. It's not actually in the actual space. It's on an actual axis line. So this is not in any quadrant. That's what you need to realize.
What was that called again?
Well, for angles we call them quadrantal angles, right, when they're in between. But for us, it's just a market lines on an axis. Okay. So that's quadrant 1. Where's 2 at?
Top left.
Top left. You're doing very random things. All right. So this is quadrant number 2. Now, why? Why is that 2? That's the way it's always been. We talked about in geometry.
It has to do with like causes and meaning.
Going counterclockwise, but what was it originally used for?
Something about trigonometric.
What?
Stars.
No. Based on angles.
Angles.
Angles work, right? Angles start on the origin, right? So an angle, this is the initial side of an angle. And then you open up counterclockwise, and this is how you measure angles, right? So this would be, let's say this is like a 30-degree angle. We always open angles counterclockwise. That's what we call standard position for an angle. Horizontal, you open up counterclockwise. So that's why they call this quadrant number 1, because that's literally the first quadrant you hit when you draw the angle. You open up, that would be the first quadrant where the angle would sit. And if you kept going, you'd eventually hit this quadrant. Let's say it's 150 degrees, let's say, going from here to here. Well, that's why that's quadrant 2. That's the next quadrant you hit when you open up counterclockwise. So you're kind of on the right thing. And then eventually, where's 3?
There.
Bottom left. And 4. Now, I'm going to pre-warn you here. If you go to a foreign country, let's say you do a foreign exchange program kind of thing, they will teach you that differently. Like I know for a fact that Italy will teach the quadrants in the opposite order. Because they go clockwise like a clock. They don't base it on angles like the U.S. system does. Does that make sense? That's a U.S. All right. But those are the quadrants that we use. Now, why it's important is sometimes it's easy to see like answers, because I know like Connor, you said, or somebody said, I think it was you who said positive negative numbers. Is that right? So that's something that we'll look at later. That's an easy way to figure out like kind of where you're going to roughly be when you're graphing coordinates. Because like, I'm only using negative numbers for this graph. Well, then that means you're in quadrant 2 and 3 and 4 somewhere, because these are where the negative numbers tend to be somehow. So I can kind of get a feel for where the graph's roughly going to be. So that's the idea. That's the idea of quadrants. Okay, now let's get to this idea of how to graph, especially like equations. We know how to graph coordinates. I'm going to ask you to do that in your homework. Your first couple of problems are where I'm going to give you a graph like this, and I'll give you a graph paper, and I'll just ask you to draw a bunch of dots. Put A, B, and C, that type of thing. Graph it in one box like this, there's a series of dots you have to put in there. It won't make any special picture, you just have to make sure you're graphing the dot in the right location. Do you think you can handle that? Okay. Number 2, you'll have to graph some type of equation, some type of function, right? And that's the ones that get a little tricky. Now they try to help you on this first section. They give you at least some structure to it. It's not just a free-for-all. So if they give you some equation like this, they will tell you what x numbers you can use. So you're going to graph x can be a -2, a -1, 0, 1, and 2. These are the only dots you can use. So those are the x numbers I have. So what I'm going to do one at a time is plug in these 5 numbers, and it will spit out 5 answers, correct? So if I plug in, let's say I plug in the -2 first for my x. What's -2 plus 3?
1.
1. That's your first coordinate you're going to draw. And it's just a dot. It's just a point. So -2, comma 1. Second, -2 for the elevator up the first floor. Okay, then we're going to plug in a -1 now. So if I plug in -1, yes, you get the number 2, right? -1 plus 3 is 2, and that's the answer for y. So -1 times 2. Plug in a 0. You get 3 out, right? This is 0 plus 3. And now here's what you should realize. This is a linear equation. What makes it linear is that there's no power, there's no multiplying of different variables together, like x's and y's being multiplied. There's no division with x's. There's no crazy powers other than 1 for the x's or y's. So that's what makes it a straight line. So you can, right now, you can probably figure out what the next number is without having to even plug in 1 or 2. So where do you think the next number is going to be?
4.
It has to be 4. And the next number will be 5, because that's how linear equations work. It's literally a sequence of numbers. You've already spotted the pattern. Now, do I connect them with a line? No. The reason why. You're only supposed to graph 5 dots. If you draw lines, that's all the dots. That's including all the decimals that are in there. I don't want to graph decimals. So you just need to use those 5 dots. Does that make sense? Okay, they're going to ask you to do that. Now, they will also ask you to graph the ones that are nonlinear equations. So on the nonlinear equations, something like this. You need to draw whatever dots they give you, whatever coordinates they're allowing you to plug in. Let's say they tell the same numbers. Don't assume anything. Don't on linear, it's very easy. You understood where the next number is going to be. On nonlinear equations like curves, don't try to make a prediction where the next dot's going to be. It may not be there. So you need to make sure you're plugging every coordinate correctly and getting the answers out. Then you can draw those. And don't connect them with a line, because that would be the decimals all in between. Okay, so that's a nonlinear equation. Anything with, maybe they put an x on the bottom, that's a curve of some type. Because eventually, if you want to get rid of the fraction, you have to multiply this over and use this. A nonlinear equation of multiplying variables together. Anything with powers, related curves, that type of thing. Okay, any questions, comments, concerns on how to graph? It's very structured. They're giving you numbers to plug in, you spit out answers. Okay, last major topic today. So we talked about graphs. It's that table. And this is one that I have a feeling that a lot of people didn't understand from yesterday. It's probably the most questions I've gotten so far. So let's talk about tables. Let's go 3, -1, 0, 1, 3, 5. Alright, so just throw out some random numbers. 8, 5, 2, 1, 7, 9. Okay. And I'm going to go with some different numbers. Let's go with -12, 5, 4. Let's go 3, 7, and -5. That's anything. Just random numbers. Okay, now obviously these graphs may not be linear, because obviously I have every single number that gives curves and all that weird stuff. But we can read off certain things about these graphs. Like for instance, we can talk about, for sure, we can talk about X-intercepts. Where do your graphs hit the X-axis? So, how I know that? X-axis numbers, if I go over this grid, if we look at where the X-axis is, and I pick a coordinate, like I think one of the coordinates we picked earlier was something like this, where this graph was 6 6, comma 0. Do we agree that it hit the x-axis? Okay. Notice the coordinate. What do you notice about all types of x-intercepts? What's the coordinate?
For the y.
Yeah, 0 for a y. It has to. For you to hit the x-axis, you cannot be on the y numbers. You have to be at 0 for the y numbers for you to hit the x-axis, wherever you're at. So that's something you need to realize. So, is there any here where the y number is a 0? So it appears that we didn't hit the y-axis right now. It appears that way. I can probably tell you right now, there's probably a 0 in here somewhere. Between a negative number and a positive number. Now it crossed from negative 12, so this coordinate, by the way, for that, this is the second graph. This is y2's graph, wherever this thing's going on that thing. It's doing something weird, right? The coordinate literally went from negative 3, comma, negative 12, and it suddenly jumped to negative 1, comma, 5. So that means negative 3, comma, negative 12 was way down here, and then 1, comma, 5 was up here. So it did something like this. So there was some 0 in between. It hit the x-axis somewhere. Do we need to go find it? No, but do you understand that it was there somewhere? Some decimal in between. Okay, and it didn't look like any of the y2 equations hit 0, maybe in there and probably in here somewhere. Hit 0 somewhere. What about y1? Doesn't look like it. Didn't even look like it went negative at any point, so I don't know if it hit 0 anywhere. Okay, so these are just two different equations. That's what you need to realize. The x numbers are just the numbers you're plugging into the function, right? These are the x numbers they're both using. This is one particular graph, this is the other graph. Does that make sense? You're gonna have it. And so, things I can tell. Obviously I can tell x-intercepts, but I can't tell a y-intercept. And like talk about y1, that function, whatever function this is of some type, it definitely hit the y-axis. It hit the y-axis somewhere. It was called a y-intercept. Because when you look at y-intercept coordinates, it'll have 0 for an x number. So where did y1 hit? 0, 2. Just let me take a look at that. 0, 2, 0 right and left, up to 2. That's a y-intercept. Definitely the y-axis. What about the second equation? So y2 is definitely at 0, 4. Okay, does that make sense now? How you're looking at the table? The x numbers are the same x's for both equations. The y number is different. So it's big on different values. So these graphs are going different places, different curves and lines going crossing. Did any of the graphs hit, like, did they intersect?
Yes.
Yes, where?
5.
Okay, yes, I agree with that. They definitely intersected, right? Spelled right. So the graphs definitely intersected. When I mean that, they definitely touched. Negative 1, comma 5. I agree. Both graphs have that. Correct? Both have negative 1, comma 5, so they definitely hit there somehow. And is there another spot? 3, 7. So somehow they're doubling over themselves in the crossing twice. Because they share the y-axis numbers. Alright. Questions, comments, concerns on any of that? Not a big deal. It's just like you're looking at a table and trying to interpret things from it. Obviously, I can't tell you where these graphs are going to go. I don't have any idea of predicting, but you can definitely get a sense for if they hit the y-axis or if they don't. If they were linear, you'd see a pattern there. They'd be a sequence, like the y numbers would be like in order where they'd be building. But it's definitely not as of this moment. Questions on any of this stuff I've talked about today? Okay. Homework on this stuff is just basic what I've talked about today. Graphing dots, graphing linear equations on a graph, where they give you certain x numbers to plug in. Looking at tables and answering a series of questions about the table itself, where things cross or they don't. And then there's certain ones where I'm going to have you graph curves. Let's see if you can graph a curve or not. Okay. So, here's your homework today. And I'm going to hand out graph paper. Alright, here you go. Okay, your homework today is page 43, sorry, 140. Page 140. 143, you're doing numbers 1 through 12. This will all be on one graph. These are they're giving you coordinates. Each problem's a different coordinate. Just put it in the same graph. Just draw the dots.
So do we need this kind of paper?
Yes, you will. For certain questions, you will. Okay? So that's 1 through 12. That'll be on one graph. I'll give you a graph here in a minute. 13 through 28. The column. It's a column. Columns go up and down. There's, I think, 5 problems there if you look in the book at the column. These you're going to have to graph on their own. So you're going to have to graph each separately. So each one will have its own particular graph. And then the last one's 29 through 46. They're giving you a table and asking you questions about it. Like, do the equations intersect? Do they hit the x-axis? Where? Did they hit the y-axis? Where? That type of thing. You're just answering a series of questions about it. That is it. You think you can handle that? Very easy. Especially these. It's just a series of questions like I talked about earlier. It's a yes, no kind of thing. Tell me where the coordinate is. These you actually have to graph, and these are just dots. So let me hand up some graph paper, and you're free to go. I'm going to make this due on Tuesday. Just notes. Yeah.
We're fun at next month, definitely.
Yeah, well,
Just keep up your build up.
We're about Wednesday.
Wednesday.
It's a Wednesday.
I know.
Yeah,
The
but
day
like,
after
one through
math,
12, I think that's just scratch.
I think we talked about the combination instructional path that we did last week.
Oh,
We've seen how we did.
Did we do okay?
We got, what was it, 12 out of 20 was the average or something like that? Outliers were 16 out of 20.
Hopefully we'll get better scores.
any hundreds?
I was 2 off or 4 off from 100. So you can't even
You
do
almost
basic.
had
There's
it.
no perfect.
Thanks, George.
No, you haven't even looked at it yet.
I really haven't done
Because the first 12 are just dots. Just draw a single dot on the graph. Use one graph for all 12 of them. Just put dots. That's all I need. Because I'm going to look it over and see if the dots match. Nope. You don't need to put anything like that. Just put all the dots in that one graph, and I will check to see if it looks exactly like mine. That's how it works. I can tell within the first second we're looking at it. Pretty easy.
What?
What?
We didn't even get to the homework. We didn't even get to the homework.
Really, it wasn't homework, it was saying you could do homework.
No, I thought it was the,
Go over read and write.
Yeah, what is the read and write?
I'm pretty sure that's
Oh, is that
the
the
SAT
ACT
prep thing. SAT prep thing.
Yeah.
Thing we got like 3 days ago.
Yeah, it was the other day.
And then she pushed our speeches to Tuesday.
Yeah.
This is like the 3rd time she's
Sure, we'll
pushed
do
it.
that Tuesday.
She's like, I hate Monday speeches, so.
Kind of stinks because Tuesday night I stayed up forever working on speeches. School Wednesday.
Come to school Wednesday, you find out you get another week to work.
And then I forgot my speeches.
Yeah. Like it would have been even funnier if Sherwood like didn't show up to school today, so he comes here Monday prepared to do a speech.
That would have been hilarious.
13, 16, 19, 22, 25.
Yeah,
Does that make sense?
Tyler did it, but Tyler did it with my name.
Oh, that one.
Tyler did
Yeah,
it with my
so
name.
you're graphing those 12 through 28. Hey, I've already had a couple questions. When you look at on the homework assignment where I wrote 13 through 28 the column, that if you look at your book, that's 13, 16, 19, 22, 25, 28. It's the column in your book. Those equations. Does that make sense? You're graphing each one separately in its own graph. And you're only using the coordinates that they give you. They give you like 6, 7 numbers to plug in. Okay, good.
Yes?
I thought you did. Oh, you don't need the last name.
Well, I have that. No, one.
Oh, wait, I think it was something.
So, are you saying we can't have what I do?
You can, let's make sure you're working on this.
Actually, better looking at that.
So how do you do it?
You know, I've been there for 3 times.
I was there last Sunday.
5 minutes.
Oh, I'm home.
Hey, Ward,
Yeah.
how do you do it for fractions? With fraction line?
How do you do it for fractions? Just guessing for the decimals, go over that many, go up that many.
So make it to like a. Right now, oh, yeah. Oh, okay.
Approximately. What's your number?
7.
Who's ready to make some money? Let's turn to the
Graph it. Backside?
Oh, do we have like a number by each one?
Are you doing them all? Or are you doing the column?
Oh, he literally just explained it.
I mean, I'm 13, 16,
Ward, are you guys label these
no one's
guys?
asking. I'll just ask you all day long.
We gotta label these guys.
Because I'm just gonna look at my graph. Hey, just make sure those dots when you're graphing those, make sure those dots are big enough that I can see them. I don't want to have to like take a microscope to try to see if you actually put a dot there. Make sure it's big. Make it thick. Okay, hey, does everyone understand the column idea like I told you?
It's just the column one.
What?
not even joking. I woke up.
It was.
I woke up and
Yes.
it was in my hand while I was sleeping, and I couldn't find it. And I'm like
We'll
looking
have
around.
multiple dots on the
And I looked at
same
my
graph,
hand.
right? So there's multiple X.
Yep. Yep. So on that one, so you'll definitely plug those numbers into your equation to see what your y value is.
Alright, I missed that one. That's negative 2. Negative 5 halves. Hold on, that negative 2.
Those are fine, but these
I know.
Oh, we can do
For this one, you like you'll square -3. So isn't that the same as -3 squared?
Yeah, but the coordinate graph doesn't really different. If you're graphing the negative I understand the results. Die.
Yeah.
Hey, just make sure that when you're doing your homework, you'll need a separate sheet of paper plus the grid. So you will be stapling those together in the very end. Okay, so just make sure you're putting your name on both of them. Just in case you misplace it.
This one's just Oh.
Yes, that's the
Things like this.
This is why we don't have nice things.
This is what happens when we already
Go into
you can do whatever you want. Pencil that gets through.
See, for me, I was.
Does that just grind your gears, Tyler?
Do not connect those dots with lines. You're only graphing the coordinates themselves. I gotcha.
Okay, so if you square a negative, it's
Positive.
better. Okay,
Because
so
you're
what
squaring.
is a negative squared? Is it negative?
They'll be at the same
Give me an
time.
example.
Like,
Those are your, right now you have all of them. So
so
the,
your thing is,
for a while.
You're going to square the x first. Right, square whatever the x number is first. Then you're going to take 9 minus whatever that number is.
so negative 3 is actually 9,
Nine.
so 9 minus 9.
The reason why here is that they didn't have this in like a parenthesis with a negative, so you have to square whatever that number is first.
Yeah, or your mom's and we just have to. Well, you should. He's assuming you're not.
Hey, when is this due?
Tuesday.
Tuesday.
Well, I can't pull my car apart anymore.
That's what I was thinking in my head, like,
You were literally down all day. Wait, did you run with Sally?
actually stealing. Yeah, he stole my pencil the other day.
Jonah!
And I'm like,
I needed what they meant. No, just steal it.
What if their paper's
No.
not? There's still an napkin. Because that's last time. So, in your eyes, you're changing what they want to be. Because if they want to be a paper towel, you're still calling them a napkin.
no, they don't call them paper towel when I find out.
Well, what if they look more like a paper towel, but you're calling them a napkin?
It's not what they look like, Connor. You assuming person. It's what they feel like.
Hey, welcome back. What were you doing today?
What's her name?
I said Bales' wife. You hate her?
No, I don't hate her. No.
No, Bailey Frank.
I love Bailey Brain.
How the fuck is Bailey Frank?
There's, okay. She just, she's a little odd. Don't tell her that I don't like her. Bryce, don't tell her.
I'm not, I'm saying I'm hanging with your BFF.
Huh? To who?
Her.
I don't, does she like almond choice? Yes. Oh, I don't know almond choice. What part did you do, Bryce?
I just said I'm hanging with your BFF, and then I drew a heart around you. So literally all I said.
Hey, what's my name?